calculus students, and welcome to lesson 2.7 on solving rational equations. And this will be a little bit of a review from some advanced algebra topics. So we'll see what we can do to brush off some cobwebs from those previous years. So this happens to deal with, we're going to solve some rational equations, but the procedure is done really to kind of help people that don't like to deal with fractions. If we can just clear them from the start, then you don't have anything to worry about. You just get rid of them and then don't have to worry about the fractions part. And most people kind of like that idea and that thought that we could do that. So that's what we're going to look at first here. And this really what I do is I look at finding what is the common denominator. And that's what I'm going to multiply every term by that common denominator. Well, this one's pretty simple in the sense that I've only got one denominator, so that is the common denominator is x. So what I'm going to do, and I'll just rewrite the original problem here just so I can have a little bit bigger, is I'm going to multiply each of these things by x. So I'm going to multiply this one by x, this by x, and this by x. Each term by x. Well, if I do that, I get x squared right here. Here, these x's would cancel out, so I just get plus 2, and then this equals 3x. And again, if I'm going to solve, this looks like a quadratic, so I get all the pieces over on one side, and I'll put them in standard form. So I'll go x squared minus 3x plus 2 equals 0. And then this is just a factoring problem. So I've got x, and then two numbers multiplied give me 2. But when they had to give me negative 3, well, how about negative 2 and negative 1? Oops, this was 0 over there. And then to solve, we know that this x minus 2 equals 0, or this x minus 1 equals 0, so x equals 2, or x equals 1. All right? So sometimes what happens is we get this extraneous solution, because when we multiply or divide an equation by an expression containing variables, okay, so when we multiply or divide an equation, the resulting equation may have solutions that are not solutions to the original equation. So we call those extraneous solutions. You can kind of see in the word there, they're extra solutions. So for this, we must check each solution of the resulting equation in the original equation. So we should go back and check each of these answers. So we go back and we put 2 back into that equation. We get 2 plus 2 over 2. Does that equal 3? Yeah, 2 plus 1 equals 3. And then put 1 in this. So we get 1 plus 2 over 1. Does that equal 3? Yep, 1 plus 2 equals 3. So they both check out. Okay, there aren't any extraneous solutions. So let's try another one, and then we'll give you guys an opportunity to practice on your own. So sorry about the mess up here. This function needs to be changed just a little bit. So that is a purposeful change on there. That should be 38 on the numerator. So when I look at this problem, I'm going to look at, well, what is the common denominator? Well, I see that there must be an x plus 4. There must be an x plus 1. And let's factor this. Hopefully they're the same pieces here. So I'll give myself a little more room there. So if I factor this, x and x, two numbers multiplied give me negative 4, but when I add it give me positive 3. How about a plus 4 and a minus 1? Great, that is. I see that that's the same thing. These are the same thing as over here. So that common denominator would be that x plus 4, x minus 1. So this is what I'm going to multiply each of these terms. Multiply this term by that, this one by this, and this one by this. So here we go. So I'm going to take x plus 4 times x minus 1. I'm going to multiply that times the first one. All right, so times 4x over the x plus 4, right, plus take again times the second one here. So you're going to take x plus 4 times x minus 1 times that 5, and that's all over x minus 1. And that should equal 38 times this common denominator, x plus 4, x minus 1, which is over x plus 4 times x minus 1. And then what's nice is because we're going to multiply it by that common denominator, we get some canceling that goes on. We'll let this one cancel with that. We'll let the x minus 1 cancel with that. And here, both of these cancel out. So now what I've got left is I've got this x minus 1 times 4x. I'm just going to write it like this because it's more common to put that out front. Plus, same thing here, I'm going to put that 5 out front. And it's nice is everything canceled out here, so this equals 38. Well, I'll just do a little distribution. This will be 4x squared minus 4x. Distribute the 5 here, so plus 5x plus 20 equals 38. I do see that this is a quadratic, so I'm probably going to want to get this 38 over on that other side. So I'll subtract that off, combine some like terms here, and I'll get 4x squared plus x. And if I subtract that 38 there, I should get minus 18 equals 0. Now then it's a matter of factoring this. We can just do a little guess and check on this. If I separate that 4x squared into 4x and x, let's see here. We need to get a positive 1. So how about, let's go minus 2, which will give me minus 8x. And then positive 9, because I need 9x. 9 negative times negative 2 is negative 18. Yep, so we got that to work. So if I set these equal, 4x plus 9 equals 0, or x minus 2 equals 0. So here, x equals 2 is a possible answer. And then here, if I subtract 9 and divide by 4, negative 9/4 is a possible answer. But like I said, we should probably check these answers back in the original problem to make sure that they work. So if I put these back in to the original problem, I'm going to go up here, put this in for that negative 9/4. So if I do that, negative 9/4 times 4 would be negative 9 over, would be negative 9/4 plus 4. Plus, we're going to have to get good at our fractions. 5 over negative 9/4 minus 1. And that should equal that 38 over, what we can do is we can put it into that factored piece there, so we don't have to worry about doing the squaring. But so negative 9/4 plus 4 times negative 9/4 minus 1. All right, I keep working this out here a little bit. This would be what, negative 9 over that 4 would turn to 16/4. 16 minus 9 is 7, so this would be over 7/4. Plus 5 over, this would be like 4/4. So it should be negative 13/4. Equals 38 over this negative 9/4. So of course we just did that one earlier, so that's a 7/4 times this negative 13/4. And if I keep working this, this is division, so it'll be a copy dot flop, so it'll be like negative 9 times 4/7, so it'll be negative 36/7 plus, and again, copy dot flop, so flip this fraction, so that'll be 20 over negative 13 equals 38 over, multiply here, so this will be negative 91/16. And I find a common denominator here now. Common denominator would be, 91. So I have to multiply this one by 13. 36, actually, we can just do this with a calculator real quick. So this would be negative 468 over 91. Multiply this one by 7, so that'd be, if I get this plus and minus here, that'd be a negative 140 over 91. This one will be flipping that around, so 38 times 16. This is negative 608 over 91. Just took that negative on the top. And combining this is negative 608 over 91. Same thing here, negative 608 over 91. So it does work. It's a little fun with the fractions there. We can try this 2 as well. So I put that 2 up there. And I'll do this in a different color just so we can separate the 2, because they're going to kind of run into each other here, I think. So I put the 2 up into the original equation. I got 4 times 2, which is 8, over 6, plus 5 over 1. And does that equal 38 over, put the 2 in there, so 2 plus 4 is 6. And times 2 minus 1 is 1, so this would be over 6. And if I do a little multiplying here, change this one, multiply this one by 6, I have to multiply this one by 6. So I have 8, 6 plus 36. Does that equal 38 over 6? And I'd say it does. So this works as well. So no extraneous solution here. But, you have to check. So, what the heck, we'll just do this one together and see how it all turns out rather than having to pause the video. So let's just do this one together. Again, looking for that common denominator, I need to have x minus 1, I need to have x minus 3. If I factor this, x and x, and guess what? Same pieces. When I go through, so that common denominator again is x minus 1 times x minus 3, and that's what I'm going to take and multiply each of these terms by. So I'm going to take x minus 1 times x minus 3 times this first one, which is 2x over x minus 1, plus, again, take that common denominator, x minus 1 times x minus 3 times 1 over x minus 3. Put that parentheses there. And this one equals 2 times that common denominator, x minus 1 times x minus 3 all over, which is already that common denominator. And then I can clear the fractions. So boom, 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 boom. This one goes, and this one goes with that one. So here I have just left 2x times x minus 3 plus 1 times x minus 1 is just x minus 1. That equals 2. Let's distribute here. So I get 2x squared minus 6x. Then I get the plus x minus 1 equals 2. And if I'm going to solve this, I see it's a quadratic, so I'm going to set it equal to 0. So I'll go 2x squared minus 6x and x is minus 5x. I'll bring that 2 to the other side, so this should be minus 3 equals 0. And then we should factor this. 2x and x. And we'll split them up here. Let's go minus 3 because that can be minus 6x. And then we get plus 1 here that we know that minus 5x. So then set each of these equal to 0 and solve. So subtract 1 divided by 2. So x equals negative 1/2 is a potential answer. And here again, x equals 3 is a potential answer. Again, this is where we want to check those answers back into the equation, see if they work. So I'll take this negative 1/2, put it in for all those x's up here, and if I do this, 2 times a negative 1/2 would be a negative 1. A negative 1/2 minus a half would be negative 3/2. plus the negative 1/2 down here. So this would be 1 over negative 1 minus 3 halves would be negative 7 halves. Equals 2 over, let's just put that negative 1/2 in there, so that's negative 3 halves, and then times, I put that negative 1/2 in here, that's negative 7 halves. So we can do that little flipping here. So this is actually, if I divide by this fraction, it's really multiplying by that reciprocal. So the negative 1 times negative 2/3. So it's just 2/3. And flip this. So this would be plus and negative, so it's minus 2/7. Does that equal 2 over, multiply here, this would be 21/4. So here now, finding the common denominator, I have to multiply, this the common denominator would be 21, so I'm going to multiply by 7 over 7 here, so this is 14 over 21. This one here I'm going to have to multiply by 3, so it's 6 over 21. Does that equal, and here when I get copy dot flop, so I have to flop this, multiply this to be 4 times 2 would be 8 over 21. And it does. 8 over 21 equals 8 over 21. So this one works. Let's put the 3 on here. And I'll go ahead and do this in a different color too. So I'm going to put the 3 up into the equation. So 2 times 3 up here would be 6. Over the 3 minus 1 is 2. Okay. Oops. Plus 1 over, you can put that 3 in there. Ooh, look at that. It'd be 0. We already got something that's undefined. So there we go. We already have a problem. So I'd have to say that this one right here is an extraneous solution, because I won't get a solution there. All right. So check that work. Check for that extraneous solution. As you can see, sometimes it happens. And you've got to be aware of that to be able to report that back out. So otherwise, work on just clearing the fractions and solving some of these rational equations. You can do that for our lesson on page 253. And you've got a handful of problems you can give a try there. All right, so again, keep on wishing you good skill.